Good evening, everybody. I think this is a important class for all the surgeons. I hope many people have attended. Dr. Ramakrishna is known statewide and nationally as one of the statistic gurus. So glad that he is with us, and he will be moderating this session mainly. I will add what little I know, and all of us have to be interactive in this session. I think a lot of questions need to be asked, and I think it's now over to Indraja to start the presentation. Indraja?
Indraja muted, I think. Indraja.
Am I audible, sir?
Yeah.
Good evening to everyone. I'm Dr. Indraja, second year surgery resident in Saga Hospital. Today, I'm going to discuss about the statistics, different types of studies, and different types of data and statistical test and their significance. Biostatistics, it is defined as science of theory and methodology for acquisition and use of quantitative evidence in biomedical research. For every surgeon should have a knowledge about the statistics to practice evidence-based medicine. It not only allows us to appropriately analyze a study, and it also enables us to present our work in a more impressive and convincing manner. Statistics, it is defined as a collecting, summarizing, and interpreting the data, and using this data to estimate the size and the strengths of association between the variables. It is a tool for converting data into meaningful information. The sequence of events in a scientific study. The study should, if we are planning for the research study, we should have a hypothesis without which we can't start a study, followed by study design and selection of the population and sample selection, data collection and analysis of the data and outcome interpretation. Hypothesis, one of the experts defined hypothesis as well-argued analysis of available evidence to provide a realistic explanation of existing facts and fill gaps in public understanding of the sophisticated process and propose a new theory or test. Hypothesis can be proven partially or entirely wrong, and the main requirement for the surgeons, like the author should be honest about the limitations of their suggestions. Study design, it is a method used to collect and analyze data on variables specified in a particular study. It can be divided into descriptive and analytical studies. Descriptive study, it consists of case report and case series and cross-sectional studies. Analytical, it is further divided into observational and experimental studies. Observational includes case control and cohort studies, and experimental includes randomized and non-randomized controlled trials. Descriptive study, it is easy to conduct. The main focus is to elaborate on one or few variables, but it neither establish relationship between the exposure and outcome, and it not try to answer any specific question. The most commonly used descriptive studies are case reports and case series. Analytical observational studies, these are used to identify the relation. Yes, sir.
Indraja, can
Yes,
you
sir.
give some examples there so that we can understand it in a better way for the previous slide?
Sir, case
Yes.
report.
Case series.
Sir, case report is
Yeah, that's fine. The next one you said, no?
case series, sir. So case series, it is a group of cases, sir. Particular.
There is no statistics. Only they'll keep on describing how the patients are presented, how
Yes.
they are treated. That's all. There is
Yes.
no statistics, no numbers. So
Yes.
that is the description.
Okay.
Next.
Can I continue?
Yes.
And analytical observational studies. These studies identify the relationship between the variables, that is exposure and outcome. The most commonly used these observational studies are case control and cohort study. Case control study, it is a retrospective study where the outcome is predetermined And investigator does a retrospective study to establish relationship between the exposure and outcome.
What is the difference between this case control study and the interventional study?
Case control study
And
Interven-
intervention, this randomized control trial or something,
so,
control study.
in randomized control study, we intervene. We'll use one
Yeah.
intervention. Sir.
Hmm.
Yes. Here we won't use. We'll just study the population.
Means case and control are already there.
Yes,
We
sir.
are not doing anything. We are just collecting data about the case and control, which are already there.
Yes, sir.
And we just analyze and give the results here.
Yes.
No intervention.
Yes. And cohort study, in this exposure and outcome to be registered are determined, and the investigator processes study in prospective manner. Analytical intervention study, the investigator perform an intervention and determine the outcome of such intervention. For example, studying the effect of a new drug or surgical technique.
Can you give example for cohort study? What type of one type of this? One example. Cohort study and the case control study. If you give example, I think they will understand it in a better way.
Yeah.
The case control study classically everywhere given is the relationship between smoking and cancer.
Yes.
You are not intervening there. You don't induce anyone to smoke. Smokers and non-smokers are already there in the population. You are just going to collect the data on them and analyze and give the results, conclusions. That is case control study.
Yes, sir.
Cohort study, you are going to select a group of cohorts. What is a cohort?
Cohort is it is a group of populations.
Of similar
population means
yes.
India is a population like yeah, that word should come.
Okay.
Sharing something in common. Something. It may be females, all females of a particular geographical area,
Yes.
all smokers of a geographical area, like that. Something common should be there.
Yes.
That group sharing something in common, they are called a cohort. You have to follow them for a long period of time, which is predetermined sometimes, and collect the data during this. So it is called prospective.
For example, if you want to study a group of, let us say, smokers,
Yes.
and see whether the exposure does the risk of cancer increase as the risk of exposure increases. For example, what is the number control? What is the number of patients who have cancer at 5 years, 10 years, 15 years, to see whether there is an exponential increase as there is increase in the number of years of exposure to smoking. So that will form a good cohort study.
Yes, sir.
Continue, ma.
Yes, sir. Okay. And, types of data, the raw data sets of observation made in a sample from the target population, and each observation is known as a variable. The data can be divided into qualitative and quantitative data.
Again, you give examples for this qualitative data and quantitative data.
Yes, sir.
What?
Here I mentioned.
Okay.
Qualitative data, it can be nominal and ordinal data. The nominal data, it consists of name, for example, gender like male or female, and smoker or non-smoker. And the ordinal data, it when the classes are not only different but also have definitive order. For example, like stages of carcinoma, like stage 1 to 4. And the quantitative data, it can be divided into discrete and continuous based on the whole numbers. And the continuous data, it can be interval and ratio data. The interval data, it consists of observations with a defined interval, for example, Celsius or Fahrenheit scales of temperature. And the interval data, it doesn't contain any true 0 point. The ratio data, it is similar to interval scale, but it does not contain true 0 point. For example, it contains true 0 point, for example, height or weight. Can I continue, sir?
This is a little bit confusing because initially we say statistics apply only for quantitative data.
Yes,
And
sir.
here you are telling qualitative data. See, there should be some way of converting this qualitative data into numbers, quantity.
Yes, sir.
Then only you can apply statistics. So this type of classification, some sources they give, but the easier and easier to understand is continuous data and categorical data.
Got it.
This is the main difference.
Okay.
Categorical data fall into definite categories like recurrence rate, infection, mortality. A patient either dies or he survives. There is nothing in between. Definite categories are there.
Yes, sir.
Whereas continuous data, it can take infinite number of values like age,
Yes, sir.
20, 25. In between 20 and 21 also you can have like 20.1, 20.3, like that. The possibilities are infinite. Such data are called continuous data. These two broad categories are very easy to understand. Of
Yes,
course,
sir.
these smaller difference and subcategories, they are there.
Yes, sir.
Yeah, this much if you understand, that's enough.
Okay.
And qualitative data is about, for example, color of the skin, or
Yes.
things like that, which are qualities but not quantities. So you can't say the patient is half red or whatever.
Yes, sir.
So it is a quality, and hence qualitative data cannot be analyzed unless you have a way of then converting this qualitative data into quantitative data. For example, you can use various scales that are available, which, for example, one example is Likert scale. Similarly, there are, for example, how are you feeling? A patient may say, I'm feeling fine, or I'm feeling, depressed. So you can then have a scale from being fine to being completely depressed or whatever, and give a score for each of them, and then convert it into quantitative data and analyze it.
Okay.
So that is the essential difference between qualitative and quantitative data.
Okay.
Yeah, the classical example given is pain. If
Yes.
just patient says pain increased, decreased, I'm feeling pain, then you cannot apply statistics.
Yes.
You use visual analog scale. You
Yes.
scale it between 1 to 10.
Okay.
And that is the way to convert the severity of pain or the quantifying the pain. Then if you have number, you can apply statistics. Otherwise, just pain decreased, increased, you cannot apply statistics.
Yes.
Yeah.
Yes,
Any
sir.
questions so far?
Chat box is empty, sir.
Chat box is empty.
Sir,
Okay.
one question.
Yes, sorry.
Sir, Sir Ramakrishna, sir. Sir, cohort study, there is a prospective cohort and retrospective cohort study, sir. I quite didn't understand about the retrospective cohort, sir. Sometimes we study in the, can you explain?
The event has already occurred and you are going to collect it over a period of time, means retrospectively. You have already started study now, and you are going to collect the data over previous few years. Then that becomes a retrospective cohort. If you are following prospectively, then it becomes prospective cohort study.
But that comes under case control. I get missed.
No. Case
confused.
control study, you are going to collect at one particular point of time. Today, how many patients are smokers? How many developed? How many of them have got cancer? So this is basically cross-sectional study. Like, you are not going to follow the patient here. So that is case control study. In cohort study, you are going to follow the patient and record the data over a period of time. That is cohort study.
See, Hari, to answer your question, the study that you did about Whipple's resection.
Yes, sir.
That, it was both prospective cohort and retrospective cohort. So same patients with carcinoma of the head of the pancreas, you studied them, retrospectively, the data you collected from the notes or whatever, and you also collected data as you went along.
Yes, sir.
So that is a classical example of, case control, prospective and retrospective cohort study.
Okay, sir. Thanks.
Any other questions? Any other doubts? Okay, continue, Indraja.
Yes, sir. There are different methods of data collection in which includes in-depth interviews, in the focus group discussions and participant observation, in which researcher becomes participant in social event or group under the study and records the observation, and web surveys. And summarizing the data, any set of numerical outcome variable can be summarized with two types of measures, which includes measures of central tendency and measures of dispersion. The measures of most commonly used measures of central tendency are mean, median, and mode. Mean is obtained by adding all the values, dividing by the number of the values, and median is the middle value of distribution when after arranging ascending or descending order, and the mode is the most frequent value in the data set.
And here you must understand what is parametric data, non-parametric data. Can you explain?
Sir, parametric data will use for normally distributed
the data which follows normal distribution curve
yes,
are called parametric data.
parametric data.
Non-parametric,
That won't follow the normal distributions.
then which curve it follows? What is the other type of curve?
Skewed distribution.
Skewed distribution curve, yes. For which one of these three is used to describe central tendency?
Sir?
See, these three types of central tendency you have told.
Yes, sir.
What is used for what type of data? Usually for parametric data, we use mean.
Yes, sir.
For non-parametric data, you use median, because the mean, if you take, it gives a wrong impression of the center point in non-parametric data. So median is more commonly used for non-parametric data, and mean is used for parametric data.
Sir, is there any place where you use mode?
Mode is also used, sir, because sometimes some of the things they have bimodal presentation. Like we say hard skin disease, it is more common between 15 to 20 years, and then again 40 to 45, like that. So two types of modes are there. Then that becomes bimodal, or usually we will have only one mode. Some of the data they show bimodal tendency. So there we use mode, especially when this non-parametric data are there.
Okay. All of you understood, no, what Dr. Ramakrishna said?
Yes, sir.
About parametric and non-parametric?
Yes, sir.
Okay, right.
Yes. No. And measures of dispersion, these convey information about the variability present in a set of data, which includes range. It is the difference between the minimum and maximum value. And the mean deviation, it is the average of absolute deviations of the observations from the mean.
See, the other one you left it, I think, standard deviation. That is more important and more commonly used. No, in that list only you have to include that, because that is the most commonly used measure of dispersion. The measure of dispersion says how the data is distributed across the range.
Yes, sir.
So there in medicine, most commonly we use standard deviation, not this mean deviation.
Okay, sir. And variance, it attempts to measure dispersion in relation to the mean. It is designated as square root of the standard deviation, and it is the deviation from the mean of each observation is squared up, and then all of them are added, which is divided by the number of values. It can be described as average square deviation. And standard deviation, it tells us about the dispersion of individual observations about the mean. It characterizes typical distance of an observation from the distribution center or middle value. If the observations are more dispersed, there will be more variability. And low standard deviation signifies less variability, and high standard deviation indicates more spread of the data.
Yes.
Yes.
I think muted, sir.
Hello. Hello.
Ravi, Ramakrishna, Heli, you have something to add? please?
No, he passed her. So she
Yeah.
passed. I think we can continue, sir. See,
Yeah.
this formula she has given, but it is difficult to remember this formula.
Yes, sir.
Better than that, what we can do, we can use this online calculators or even this Excel file where you can calculate these things very easily. So it is difficult to remember this formula and the method of calculation. Okay, proceed.
Can I continue, sir?
Now, those n1, n-1, two things you have mentioned.
Yes,
You
sir.
have to understand what it is. What is the difference between those two?
Sir, N will use in population standard deviation, sir.
Hmm.
And N-1 in sample standard deviation.
If you are using whole population,
Yes,
you
sir.
have to use n.
Yes, sir.
If you are selected a particular group of patients, like you are sampling,
Yes,
and
sir.
you are using the standard deviation, you are calculating standard deviation, then you have to use n-1. That will show some sampling error will be there.
Okay.
If you are calculating the standard deviation for the whole population, you have to use n.
Yes, sir.
If you are sampling, you have
Yes.
done sampling and you are calculating standard deviation, then you have to use the
Yes.
number n-1.
Okay, sir.
That's the difference.
And the categorical outcomes, the proportion, it is the number of individuals who experience an event divided by the total number of the total number in the sample. Proportion is used to estimate the probability or risk. Risk, it is a ratio of the probability of exposure outcome under consideration to all possible outcomes. And the relative risk ratio, it is defined as a ratio of risk in exposed group by ratio of risk in non-exposed group. It is calculated as incidence of disease in exposed by incidence of disease in unexposed. If the relative risk is 1, the exposure is not associated with disease. If it is more than 1, exposure is positively associated with the disease. And if it is less than 1, and exposure is negatively associated with the disease.
What is the meaning of that? Negatively associated with the disease means what?
So if it is more than 1, the exposure is like the patients who are exposed or developed the disease, sir.
And
negatively
associated means,
like even after the exposure, they didn't develop the disease.
No. When they are exposed, the
Yes.
disease occurrence will be less in those patients.
Okay.
Like if you give some particular vitamins or iron,
Okay.
those patients will develop the percentage of anemic patients in that group will be less than unexposed.
Yes.
That means it is a better thing.
Yeah,
Because
that intervention has a salutary effect on the disease.
Yes.
Understand? There is an exposure to something.
Yes, sir.
Risk is more than 1 that actually does harm, causes harm. And
Yes.
less than 1, it actually does good.
Okay.
It's not a passive, no disease equation. It is not passive. It's an active intervention which helps in the prevention or treatment of the disease.
Okay. Sir.
Yeah.
Okay. Sir. Can I continue, sir?
Yes.
In the odds ratio, it is measure of risk used for a retrospective study. And the term odds denotes ratio of probability of success to probability of failure. And odds ratio, it is calculated by odds of case in exposed group.
Madam,
Yes, sir.
please go a little slowly. Huh?
Sorry.
Thank you.
Yes, sir. Odds ratio, it is calculated by odds of case in exposed group by odds of cases in unexposed group.
What is the difference between odds ratio and risk ratio? Risk and odd. Ratio, of course, exposed, non-exposed, but the difference between odds and risk.
Sir, I'm not sure.
See, odds, the occurrence versus non-occurrence.
Yes.
It is A by B.
Yes, sir.
Whereas risk, you are taking the total A by A plus B.
Yes, sir.
So if smoking causes cancer, if you are taking only cancer means, if cancer occurs in 90% patients, it means 10% will not develop that. So that means 90 by 10, that is the odds.
Yes, sir.
If you are calculating risk, it becomes 90 by 100 because you are considering the total number. So that is the difference. If the sample size is very large, they both becomes almost equal. They will be different if the sample size is less, like 50, 100, like that. If you are taking very large size, like 10,000, 1 lakh, then the difference between these two will be very minimal, risk ratio and odds ratio.
Okay, sir. And if it is equals to 1, the odds of exposure among case and controls are same. And if it is more than 1, exposure is positively associated with the disease. And if it is less than 1, exposure is negatively associated with the disease.
Yeah, interpretation is more or less same as risk ratio.
Okay.
Same.
Okay. Confidence interval. In descriptive study, the results are obtained as estimates, and the results are reported in percentage of confidence interval. It displays the probability that a parameter will fall between a pair of values around the mean. It measures the degree of uncertainty or certainty in a sampling method, and the most commonly constructed confidence levels are 95% and 99%.
Give an example how you express it.
So 68%, yes. 68% confidence interval means the 68% of chance of the parameter to fall under this blue area.
No, you give one example, means where you have expressed confidence interval. What are the numbers they come across in expressing confidence intervals? See, you should mention mean plus or minus standard deviation, then in bracket confidence interval, so and so percentage, like that. For example, 90 plus or minus 10, CI 95.
Okay.
That's how you express. That means it's not the probability of falling, because if you have already taken the sample, it will be a single number. It cannot be spread across it. If you keep on repeating the same experiment 100 times, 90%, 95% of the times it will fall within this range.
Okay.
That's what it says. That you should understand correctly. That means it is expressed in terms of sampling error. See, when you sample it from a whole population, there are chances of getting some errors there. So once you may say, for example, exit poll after election, one paper says 85% votes will be there for BJP, another says 80%, another says 90%. So if you calculate the confidence interval, if 100 people does this exit poll, 95% of them will say it is between the whatever value you give, 90 plus or minus 5 or 80 plus or minus 6, something like that. So that is the interpretation of confidence interval, not that so many percent will fall within this range.
Okay. Okay.
Yes, continue.
Yes, sir.
So is it always 95, sir?
No, usually in medical statistics, we keep confidence interval as 95% because we want 95% confidence in our conclusions. So we keep it at 95. It is an arbitrary value, just like p-value. Yeah, continue. Hello.
Raja?
We lost her voice.
She lost voice. Indraja?
Hello. Somebody has to call her, I think.
Yes, sir, I'm calling.
Hello, Pavan,
Sir, she is connecting again, sir.
Huh.
1 minute. Sir.
Janani? Is Janani in the class?
Sir, she was there till now, sir. Just she messaged, says she'll join back in some baby.
Hari, did you understand the concept of 95% confidence interval?
Yes, sir. I understood, sir.
Huh.
Sir, actually, it is what I understood is like, for example, the study population. So 95% of the probability to chance fall in that ratio. That is 95%. For example, the sir gave example. So what are the chances of winning? The winning percent is arbitrarily taken as 95. The two plus or minus 5 overall chances of that will be the confidence interval for that particular study. Is what we understood, sir.
No, I think you have not understood it at all. I think what sir said and what you are saying is totally different.
Okay, sir.
See, the concept is once you have taken the mean, usually that is for the mean.
Yes, sir.
So mean plus or minus standard deviation they mention.
Yes, sir.
That means 90 plus or minus 10, something like that.
Yes,
and
sir.
then in bracket they mention CI 90, 95, whatever confidence interval they have. That means if you take the mean of whole population, it cannot be a range. It has to be a single number. It cannot be between 80 and 90 or 90 to 95. It cannot be like that. It has to be a single number. But the problem is we don't know what number it is. So when we have sampled it, because one particular set of patients you must have, you could have taken in one particular sampling. Another investigator could have taken another set of population. So the mean of this and that will differ from each other. This is one of the sampling errors. To express how much of confidence is there in the number we got or the conclusion what we give as the mean, that is expressed as confidence interval. That says if you have done the same method and to calculate the mean 100 times, 95% of the times your mean will fall within this range. That's what it says, not the percentage or confidence of falling the particular mean within that range. It is usually referring to mean.
Okay. So mean 100 times repeated, how many times it is coming for the same set? Like that.
With the 100 times, 95% it will be falling within this range, what you have mentioned.
Okay.
So that mean
5%
will
will be falling outside that.
So that mean will be expressed as mean plus,
plus or minus standard deviation.
Standard deviation, 2 or 1 on either side, whatever it is.
Okay, fine.
Yes, 90 plus or minus 5 means it could be 85 to 95.
Yes, sir.
So if you repeat the experimentation 100 times, 95% of times it will be falling between 85 and 95.
Okay.
In 5% cases, it will be either less than 85 or more than 95, something like that. That type of interpretation it gives. I think she's back.
Yes,
continue.
Yes, sir. Oh. Hypothesis testing in analytical studies involve testing of hypothesis, and null hypothesis is defined as there is no difference between the outcome of 2 or more groups. And the alternative hypothesis, it defines as there is difference between the 2 groups. The null hypothesis, it is the hypothesis to be tested, and which involves statistical tests that help in deciding whether the null hypothesis is to be accepted or rejected. And the p-value, the probability that the difference between 2 groups is entirely due to the chance, and most studies choose p-value of 0.05 as the cutoff for rejecting the null hypothesis and accepting the alternative hypothesis. And the errors, all hypothesis testing methods have inherent errors, which includes the type 1 error. It is the rejecting null hypothesis when it is actually true. When the cutoff of probability value is set as 5%, this means we would wrongly reject the null hypothesis 5% of the time. Since the standard alpha error rate is 0.05. The alpha error, it is also known as level of significance. And there is 95% probability that any given confidence interval will contain true population mean, and there is 5% chance that it won't. So this 5% is known as level of significance. Can I continue, sir?
Yeah, if there is any confusion, see, all tests of significance initially assumes there is no difference between the groups.
Yes, sir.
That we call null hypothesis.
Mm.
So then we proceed to calculate the p-value.
Yes.
If our assumption or null hypothesis is true, then the p-value will be more than 0.05. That is, the chances will be more than less than 95%.
Yes.
So if on the contrary, if you get p-value less than 0.05, that means our initial assumption is wrong. That means there is difference between the group.
Okay.
That's how we proceed with that.
Okay.
So in almost all these tests of significance, initially we assume there is no difference between the groups. Then we calculate p-value. If our assumption is correct, p-value will be more than 0.05. So we accept null hypothesis. If our P says it is less than 0.05, which is not expected if there is no difference between those two, then we reject the null hypothesis. So we accept the alternate hypothesis and we say there is difference between the two groups, two or more groups, whichever you are comparing.
Okay. In the type 2 error, it is accepting null hypothesis when it is actually false. And the value 1 minus beta gives us the probability of correctly rejecting the null hypothesis, and it is called the power of study. And the beta error value is more complex and depends on the various factors like population and sample means, sample size and alpha error. And the beta error of 20% is considered acceptable, and this corresponds to power of 80%.
It means if it is high power study, the false negativity will be less. The lesser the false negativity, higher is the power of the study. So if you have to have higher power study, you should have larger population, larger sample size. That is the problem. If you, ideally you should have 95%, but it requires a very large sample size. So practically most of the study, they keep power at 80% to calculate the power sample size. If power of the study is kept at a higher level, then the required sample size will also go higher.
And sensitivity and specificity. Sensitivity, it is the percentage of true positives. Like 90% sensitivity means 90% of the people who have the target disease will test positive. And the specificity is the percentage of true negatives. Like 90% specificity means 90% of the people who don't have the target disease will test the negative.
Like usually think it is the other way around. Usually we say sensitivity of a test. If a test has got 90% sensitivity means 90% of those who have tested positive will have the disease.
Yes, sir.
It is the other way around. The 90% of those who tested positive will have the disease.
Okay.
And here 90% of the patients who tested negative will not have the disease.
Okay. Okay. Can I continue, sir?
Yes, yes.
And the
Because
sampling
that statement is little bit confusing what you have mentioned. That's why
yes.
I told.
Okay. The sampling distribution, it can be normal and non-normal. Normal distribution, it is known as Gaussian or bell-shaped or parametric distribution, and non-normal is skewed distribution. And the parametric test used for the normal distribution curves, and the non-parametric test used for the non-normally distributed curves. And the different statistical tests, these includes parametric and non-parametric tests. I'm going to explain in the further slides. T-test, it is the measure.
That in the previous slide, you have mentioned one sample T-test, what it is?
Sir, it is like T-test only, sir.
Where do you use that?
It is used to measure the mean of two given samples.
Then two samples are there. There you have mentioned one sample. See,
with
here,
standards, sir.
Pardon?
Standard, maybe standard.
Yeah, it is measured against a standard. You already know what is the mean of a particular group and the sample mean, whether it is same as the standard mean or it differs significantly from the standard mean. So you have only one set of data there.
Okay.
For those cases, you use one sample test. Here, this what you are mentioning, it has to, you should have two samples, two normal distribution or two sets of data, two sets of parametric data.
Yes.
And for paired t-test,
Paired t-test, it is a difference between two variables from the same population.
it is difficult. See, each subject should have two values. For such things, you should, that means one pair of data for each subject. Then you can use paired t-test.
Okay.
So if you give examples, it is more understandable because you are not mentioning examples here, only mentioning the statement. It is a little bit confusing.
Okay.
T-test, you need two sets of data and it should be parametric data.
Okay.
For paired t-test, same. There also it should be parametric data. Each subject should have two values.
Yes.
Then only you can use paired t-test. That means a pair of data for each patient. Like if you have done surgery for pain reduction, each patient will have pain before surgery, pain after surgery. Weight reduction, weight before surgery, weight after surgery. Means each patient will have one pair of data.
Yes.
In such cases, you should use paired t-test.
Yes.
If it is not there, then you have to use independent t-test. That's t-test is also known as independent t-test. That means those data are totally independent. Here, paired t-test, those two data are dependent on each other.
Okay.
For different subject, it is independent. For the same patient, one set of data is there. That means a pair of data is there. Those two data are dependent on each other. There it is dependent t-test. That simple t-test means independent t-test.
Okay. So, sir, student t-test and
this is called independent
t-test.
Okay.
Yeah.
T-test, independent t-test, student t-test, or this Gossett's t-test, they all mean same.
Okay.
Initially, that person who discovered it, he used a nickname as student. He didn't want to reveal his name.
Okay.
He used the nickname as student. That's why that name came, student t-test. Otherwise, it is Gossett's t-test.
In jet test, it is used to determine whether the two population means are different when the variances are known and the sample size is large. And in jet test, mean of the population to be compared. The parameters used are population mean and population standard deviation. And this is the equation for the jet test. And the ANOVA test, it is used to check if the means of two or more groups are significantly different from each other. It checks the impact of one or more factors by comparing the means of different samples. And in hypothesis tested in ANOVA is null hypothesis means all pairs of the samples are same. That is, there is all sample means are equal. And alternative hypothesis is at least one pair of the sample is significantly different. And the chi-square test, it is used to compare two or more categorical variable. It allows assess whether the observed frequency are significantly different from the expected frequency. And in this, null hypothesis means variable X and Y are independent. And alternative hypothesis means the variable X and Y are not independent.
The group, if you are comparing, the other way of putting it is if you are comparing two groups, both groups are different. Both groups are same.
Yes, sir.
There is no difference in the incidence of particular outcome in these two groups. If it is different, the incidence is different, like that. HO means there is no difference between the groups.
Yes, sir.
HA, that is alternative hypothesis, there is difference in the incidence of outcome between these two groups. If there are more than two groups, it just says there is difference, but which two groups differ, it doesn't say.
Okay.
If it is a 3x3 table, many groups are there. It just says one of the groups is different, but which group is different, which group is not different, it is not possible to say with one chi-square test. Probably you have to calculate chi-square for each and every group to see whether there is difference.
Okay.
Interpretation is easy in 2x2 table because you know only two groups are there, and you know which one is the better. So you can say this particular group is better than other group. But if it contains more than two groups, then you cannot say which group is better, means which group is different. It just says one of the group is different.
And Wilcoxon sign rank test, it is a non-parametric test. It ranks all data points in order and calculates the rank sum of each sample. If and it compares the difference in the rank sums. If the groups have similar scores, the rank sums will be similar. If the score of one group is higher and lower than the other group, the rank sums between the two groups will be further apart. And this is each observation will rank according to the order, and each group, the ranks will be summed up in each group, and the sum will be compared between the two groups. And Mann-Whitney U test, it is a non-parametric test to compare the outcomes between the two independent groups. It is used to test whether two samples are likely to derive from the same population. Some investigators interpret this test as comparing the medians between the two populations. Can I continue?
In summary, if the data of two groups, two continuous variable are there, two groups are there. If it is parametric, use student t-test. If it is non-parametric, use Mann-Whitney U test. That is the bottom line.
Okay. And test for assessing the association between the variables. This includes correlation and regression. Correlation, it represents the relationship between the two variables, and correlation coefficient express the degree and direction of the relationship. The position is not determined in this, and the correlation coefficient varies from -1 to +1, where the -1 represents negative correlation and +1 represents the positive correlation. And Pearson correlation coefficient is most commonly used.
Can you give example for two variables which are correlating with each other? Give one example so that we can understand it in a better way. One for positive correlation and one for negative correlation.
Like smoking is associated with the lung cancer. You can has a positive correlation.
Yes, sir. Correct. So there it that smoking may or may not be cause for the cancer.
Yes.
It just says they are correlating with each other. They are associated with each other.
Yes.
Smoking may or may not be cause for the cancer. That's all the correlation says. If you are assessing the cause, then you use a different criteria for that. Here it is only saying it is correlating or associated with each other. One example for negative correlation.
Indraja, are you there?
Yes, sir.
Anybody else?
Yes, simple things.
Hari, Janani is joined back or not?
Yes, sir.
Janani, unmute yourself. and
Sir,
give
yes,
us
sir.
Negative correlation.
Sir, negative correlation, it is, sir, I'm not very sure, sir. Example, can I mention the example, sir?
Yeah, that
Yeah,
is what we
mention.
want.
Sir, for example, when we compare two different things which are not related, like the height above the sea level and the temperature, that is increase in height and correlating it with the temperature.
No,
So when height increases, temperature decreases.
Yes, sir.
Yeah, fine.
So that can be negative correlation.
or
Okay.
medically, commonly, for example, breastfeeding is negatively correlated with incidence of breast cancer.
Yes.
So that is a more common example that we can give.
You can, when reading the journals, we come across such correlations so many times. And while reading any chapter, any disease, just you have to think and use that. That's all. As sir said, that is one of the best examples. You should mention the medical examples more often than this non-medical. Yes, okay, continue.
In the regression, it allows the prediction of one variable from the other, and regression coefficient, it measures the change of one dependent variable from the another variable. And linear regression, it is used to predict the outcome of continuous data. And the logistic regression, it is used to predict the outcome of discrete data.
So what is the difference between correlation and regression? What do you understand? Because both look somewhat similar.
Yes, sir.
It is between two variables. It may be positively or negatively associated. So what is the basic difference between correlation and regression? See, in regression,
maybe variable two outcomes are regression, many continuous variables, sir.
No. The basic difference between correlation and regression is, in regression, you are quantifying it. You are going to calculate one variable if you know the value of the another variable. In correlation, no such thing is there. It is just says they are associated. It may be the strength, means the stronger association may be having more coefficient. All those things are there. But the actual quantification, that is measurement. For example, if you know weight, you can calculate the height with that particular nomogram or something like that. Or the other way around, if you know the height, you can calculate the weight. If you know the weight, you can calculate the height, like that. In actuarial survival, if you know one particular variable, this is the 5-year survival. If that value changes, this becomes the 5-year survival. Like that, you are going to calculate the outcome, or you are going to measure it, quantify it. That is regression. In correlation, it is only association you are going to tell. That is the basic difference.
Okay, sir.
In linear regression, use it for continuous data, and logistic regression for discrete data, that is categorical data.
And these are the different tests for the correlation and the regression. For the continuous outcome, linear regression, and the categorical outcome, will use a logistic regression analysis. So in conclusion, the choice of statistical test used to analyze in the research data depends upon the study hypothesis, type of data, number of measurements, and whether the data are paired or unpaired. And the statistical technique needs to be carefully chosen and specified in the protocol prior to the commencement of the study, and to ensure that the conclusions of the study are valid. Thank you, sir.
Yeah, you have done a good job, but I think you could have added a few lines about this online statistical calculators, how to calculate p-value using for various different tests, how to calculate sample size, all those things. Online, free as well as paid are there. Those things you could have shown just to impress upon that the calculation part is not that difficult once you understand the basic concepts.
Okay.
Otherwise, it was a good presentation. Sir, comments from seniors, sir. Sir Lakshman, sir.
Yeah, good presentation. As you have already heightened, it is important to understand the application of all these definitions. You gave the definitions correctly, but you don't remember them, 24, 48 hours later, unless you remember, unless you correlate them, associate them with specific examples in the kind of clinical scenarios that you normally see. So I urge all the youngsters to keep on in their minds thinking about the practical applications of all these tests. Thank you. Yeah.
Thank you.
I think I second what Dr. Lakshman and Dr. Ramakrishna have been saying. The other thing that one clue to all the students is, as and when you read a particular journal article and the new statistics comes up, or any statistical analysis is pointed out, even for example, it may be Mann-Whitney or Wilcoxon, just go back and read up about that. So and then understand whether they have applied the statistics correctly. So one is that you will probably, if you keep reading, you will understand what is Mann-Whitney U test or Wilcoxon rank test. And then you will also understand whether the test has been applied correctly. So I think it will aid you in different ways. And any new test, anything that is new that comes up in the statistical analysis, please go back and spend 5 or 10 minutes to read up, so that if you keep on doing that, it will refresh your memories. We are not going to become statisticians, but we are going to understand whether the right statistical method has been applied to in this particular thing, and it will help you to gauge the paper better.
Sir Shrikant, sir?
No, sir, I am a student. I have just joined to learn. Long back, I had requested Dr. Lakshman to arrange this class.
Any other?
Sir Ramakrishna sir, I think your comments will be very much appreciated.
Sir,
Where these tests are used, in which significance they should have added that. One more.
there is a software for that also, sir. I think she skipped that software part. If you search online, if you know what type of data you are dealing, there is a software or online application where if you feed it what type of data you are dealing with, it suggests you what test you have to use. There is what test to use. There is a separate online suggestion is there. Only thing you should understand your data, whether it is continuous variable or categorical variable, whether it is comparative study or it is survey, like that. Those things you should understand. It asks you certain questions, what type of data you are having. Once you click it, then it will suggest what data, what type of test you have to use. And using test is also very simple. Only thing you should know your data, feed it properly. Test results will come automatically within a few clicks. It's very easy, sir. Actually, I have been showing it in our workshop. Tomorrow also there is a same talk is there. I think you can log in. The problem is they have given me only 15 minutes there. So we have to condense it and skip many things, and I'll try to finish it. I am concentrating more on this using this data, how to calculate on the online easily, and more stress on the basic concepts, when to use, what not to use, and what are the criteria to use it. Those things we must understand.
So the most important thing in this class is, first is that you have to be honest in your data collection. You have to have a protocol. Better to have a proper protocol which has been studied properly, and collect the data honestly, and then apply the correct statistical analysis. And don't fudge your data, and present your data as it is there, and apply the correct statistical analysis. You may not necessarily prove a point, but even a negative, for example, if the test is negative, still it is an important test, and it is still should be published or should be presented, because it is not always that some positive association is important. I think even negative association is also a good thing. So I think honesty in data collection and presentation is extremely important. I think if there are any other questions from the students, Abdul, are you there? Hello?
Yes, sir. No,
Any
sir.
questions? Any
Nothing
doubts?
as such.
You
But it was a
understood
nice
everything?
class, sir.
Okay. Kavya?
No, sir. No questions.
Okay. So I think all of you kindly, I think anyway, this will be, this one, it will be put up in our group. All of you just go back and go through the presentation again, because I think statistics is a very nascent subject. It will, as sir said, you will forget it tomorrow or day after. So if you please, revise it from time to time. Okay.
Okay, sir.
No
right.
further questions?
Yeah.
Yes, sir.
Yeah.
Lakshman, sir.
Thank you and good night. We will close.
Thank you and good night. Thank you.
Thank you, sir.
Good night, sir.
Good
Thank
night.
you. Thank you.